So how does a computer work? And I suppose you've already kind of said to yourself, well, geez, we've looked at fetch, decode, execute, and all these memory and different things. But we know that memory stores information, that the CPU processes information, and that the bus transports information. We're now going to look at what that information is. Computers use the symbols 1 and 0 to represent the presence of or lack of an electrical signal. So often these are referred to as on or off, or high and low, or black and white, whatever you want to think of it of. But basically, is a current flowing or is a current not flowing? So our components, memory, bus, CPU, are all electronic devices. They work by controlling the flow of electrons known as electricity. If any of you are doing physics or maybe a bit of chemistry or whatever, you might have done it back in junior cert in science. When you complete a circuit, what's happening in a circuit is electrons are basically pushing around in a loop, fighting each other. It's like current running around that circuit from start to the end, and then goes pushing again and keeps going as long as the circuit's on. If you in some way break that circuit, the electrons, it just stops. The flow of electrons, our memory can be thought of as a snapshot of this flow at a given time. The flow of electrons can be measured as a current. The higher the current means more electrons, means more electricity. So, manipulating the electricity, this is achieved with electronic components such as resistors, capacitors, and transistors. Three main components that you just need to know about. A resistor, like the name suggests, is a device that reduces or resists current flow. Typically, this is achieved by passing electricity through a material that allows electricity to flow, but not very efficiently. It's like putting something in the way. Try and think of a football analogy there. Jack Jennings there playing centre back, and someone passing the ball through the middle. Jack stands in the way of the person and blocks them off a bit. They can't get through as freely. So the resistor, it resists that current flow going through. Often this converts some of the electricity to heat, reducing the current flow through the resistor. Here's a transistor. Transistor allows small current to control a larger current. So this is just amazing the way that they're like tiny little switches. You can turn the switch off, no current flowing. Or you can turn the switch on and allow a small amount of current, or based on how you have the circuit configured, you can turn the switch like kind of off, but that might only allow a small bit of current to flow. Or you might turn the switch on and that might trigger a larger amount of current to flow based on a small bit going through. It's just amazing the way transistors is effectively a switch which allows a small current change to switch on or off a larger current change. And resistor, again, is a device that reduces current flow. Typically it's achieved by passing electricity through a material that allows the electricity to flow, but not very efficiently. I thought we already did that one. And a capacitor here, this works in tandem with transistors and is basically like a bucket of water. The transistor acts as the switch to allow the current to flow. The current then flows into the capacitor. Think of a bucket filling up. And that bucket fills up, and then the computer can read that at the CPU and can detect whether this current, the capacitor is full, 1, or the switch is turned for the transistor, that capacitor empties, 0. We'll see that in more detail tomorrow. Capacitor phone screens work on capacitive principles. When you touch a certain area of a phone screen, the capacitance changes, and this is due to the fact that you and your skin can conduct very small amounts of electricity. That change, the charge under the skin, which is how the device knows where on the screen you are touching. Your finger is only making a very small change in the electric charge, but is enough for the phone to recognize. And capacitors can be used as computer memory. When they receive a signal, they store it before discharging. As I was saying, think of a bucket, water filling up, stores something that's like a 1 and discharges it, nothing in it, that's like a 0. You know, so it can store some piece of memory before it passes it on or discharges it, not uses it anymore. And that's basically it there. And transistors, capacitors, and resistors offer mechanisms to control current flows to achieve a wide range of objectives.